Guys, we're going to go ahead and get started on the video. And what we're going to be talking about is our lab that we did the other day on single replacement reactions. So you need to have a couple of things out. So let me just tell you what you need out, and then I suggest you pause it and get those things together. So one is you need your lab sheet. The second thing you need is your periodic table. You need the laminated one for sure, because we're going to need a couple of the tables that are on the back side. Also, if you have your periodic table that has all your charges listed on them, then I would also get that out. So pause and get those things out. The lab that we did was single replacement. If you'll remember, we had different metals that we mixed with aqueous solutions. And what we were trying to determine for each one of those was the element that we were looking at stronger than the cation in this case. Okay, so in other words, for this reaction, we were looking to see, is iron greater than copper in terms of strength and more reactive? Okay, so for your lab, what you did, excuse me. So what you did is you had to take your reactions that you had, and you're going to count each one of them. So we counted aluminum, and we said, how many times did aluminum react? We counted copper. How many times did copper react? Magnesium, and so forth. And then what you did is you made a claim here as to which you thought was the most reactive and which you thought was the least reactive. Now, had you been in class and had we had time, we would have gone around to each of the groups and we would have seen how each person or each group lined up the metals in terms of most reactive to least reactive. And then we would have come up with a consensus for the class, and then compared that to what we know as our known value of reactivities. Okay, so what we're going to really look at is the word reactivity. Which one of the metals is the most reactive? And when we're talking about being reactive, we're talking about whether or not it wants to gain or lose electrons. So if you'll remember, we talked about earlier that if you have something that only has one valence electron, then it's going to want to lose that electron pretty easy, versus something that has maybe 5 valence electrons. It's not going to want to lose very much. So that's what we're talking about in terms of reactivity. So what chemists have done is they have actually put together what we call an activity series. So basically, it's just a list of which things are the most reactive, which are the least reactive, so that we can use that to then do what we call a prediction of product. Okay, so if you will get out your periodic table, the laminated one that has the tables on the back side of it, up in the far, so here's our polyatomics that we've been doing, but over in the upper far right corner, what you're going to see is this chart here, and it has metals and non-metals. And so this is what we call our reactivity series. And the most reactivity, so we've got them ranked, is going to be at the top. So lithium is going to be the most reactive, then rubidium, potassium, cesium, barium, strontium, calcium, so forth. So there is our most reactive metals. Now, let's compare those to what you were looking at, and I'm going to show you what some of the other classes came up with as their most reactive. So if you'll look at yours, and we're just going to do a quick comparison here. So most of the groups that did this put magnesium as being the most reactive. Okay, magnesium as being the most. From there, generally it was zinc, lead, iron, copper, and aluminum as far as the reactivity goes. So we're going to compare it to what it actually is. So come over here to this table, and what I want you to do is start at the top and go down, and you're looking for these 6. Okay, you're looking for these 6. So as I go down through the list, now these are just ones we didn't use. Okay, we're only looking for the ones we used. And if I go down through here, you will notice magnesium is the first one we come across. And so of our 6, yes, magnesium should have been number 1, the most reactive. Okay, we're going to continue on down our list, and you'll notice aluminum. Now, we put aluminum at the bottom is what most people did, when in fact it should have been number 2. Now, I will tell you, I have done this lab, 20, 30 years, and we never get aluminum to be where it's supposed to be. I think sometimes it's just the fact that maybe it's my aluminum. I thought it was because I used to use aluminum foil versus aluminum straight metal. I thought maybe the aluminum foil had something on it, but for whatever reason, I have never got aluminum to be up here at the top. So we're going to go on down. The next one you see is zinc, which is what we have. Okay, continue on. Iron was number 3. We actually show it to be number 4. On down, here's lead. It's number 4. And then copper at the bottom coming in at number 5. So if we take out aluminum, just because for whatever reason that it doesn't seem to work, if you'll look, we're really pretty close. 1, 2, we've got these 2 switched, okay? And then copper in its right spot. So for most of the other classes, we found the activity series to be pretty much exactly what it was supposed to be, okay? So you can compare yours and go ahead on your conclusion here. Will you go ahead and use that as evidence and compare yours to what it actually should have been? And how do you line up in terms of getting that correct? Okay, so if you'll flip over to the back side of your lab sheet, I'm going to actually show you how we're going to use this activity series to do what we call predicting the product. So in this case, you've been given the reactants. We have silver and potassium nitrate. Now, we are going to be doing the reactivity of metals. And so the first thing that we need to do is look at our reaction and determine which one of these are the metals. Well, we know silver is and potassium is. Okay, silver and potassium. So those are really the only 2 things I'm going to be looking at, even though I need to use the nitrate within our compound to see if this reaction takes place. I just use the silver and the potassium. So again, what I'm going to ask is silver greater than potassium? In other words, in my chart, is silver higher than potassium? So I come to my chart and I find silver and potassium. So here's potassium, it's way at the top. I come down, here's silver way at the bottom. Okay, I'm gonna slide that on up. So potassium's up here, silver's down at the bottom. So potassium is greater than silver. Potassium's greater than silver. So this is, in fact, not a true statement here. Okay, since we saw that silver was not greater than potassium, then that just means that silver won't knock off the potassium. So this is going to stay. And so we just say this is no reaction. Nothing's going to happen. So if our statement is not true, it's going to be a no reaction. Okay, let's go on to the next one. So we have silver being our metal. Sorry, that's zinc. Zinc being our metal and silver being our metal. So again, in order for this to happen, zinc, which is by itself, has to be greater than the silver, which is attached to the nitrate. So what we're looking for is silver greater than, gosh, I said that again. Is zinc greater than silver? Is zinc greater than silver? I'm going to go to my chart. I want to know, is zinc, here it is, greater than silver? So yes, it is. So zinc's up here. Silver's down here. So zinc is greater than silver, which means that this reaction is going to take place. So what happens, again, is zinc is going to replace silver. Zinc is going to replace silver. So I'm now going to write it as silver, zinc, nitrate, Okay, zinc replace silver, and it knocks off the silver. Okay, now you're not done, because the next thing we have to do now is to make sure that our compound here is balanced. So this is now when I go to my charges. So zinc is a +2, nitrate is a -1. So I'm going to need 2 nitrates. Okay, so that becomes our reaction. Now then you do need to go back in and balance the reaction. So I have 2 nitrates, so I'm going to need a 2 to be put right there. Give me a bigger marker. I copied this worksheet and I did not leave space for your coefficients. So 2 nitrates, that now makes also 2 silvers. So I put a 2 silver there. I think everything else looks good. So we really have 1, 2, 1, 2. And, you know, of course, people ask, do I need the ones? No, you don't need the ones. And that's all you have to do to the problem. Okay, I'm going to do one more for you here, and then we'll stop this video. So the next one is going to be aluminum. And in this case, again, our sulfate is over here. So the hydrogen is going to be what we're looking at is aluminum going to replace hydrogen? So is aluminum greater than hydrogen? And it will be the hydrogen gas on there. So is aluminum higher than hydrogen? Again, here's aluminum. Here's hydrogen. So yes, aluminum is higher than hydrogen. So that means that this is going to react. So again, I'm going to come in and I'm just going to take aluminum and put it where the hydrogen was at. So I have aluminum sulfate, and it knocks off then that hydrogen that it replaced. And remember, hydrogen is a diatomic, okay? So it's got to be an H2. Don't forget that. And so now I'm just going to again check my charges. So aluminum is a 3+, sulfate is a 2-. And remember, we just crisscross. So the 2 comes here and the 3 goes there. Okay. So again, remember, we are using the polyatomic chart and or your periodic table with your elements on them. Your next step again is to balance. I'm going to get rid of a few of my little things I put on here. I need 3 sulfate, so that's where I'm going to start. So I'm going to put a 3 in front of my sulfate. That now gives me 6 hydrogens. So I need 3 here. There's 6 hydrogens. I have 2 aluminums, so I need 2 aluminums. Okay? So we're going to stop the video on this one, and we'll pick up in the next video on some of these.